when we consider the transient analysis, the very first thing that we have to remember is what is the order of this, or you consider this as a first order system. What do you mean by first order system? First order. Okay. Now, let us consider an RC, simple RC network. This is an R and C. You can draw along with me. This is a simple RC network. You have an input voltage EI. This is R, this is C, and this is I. Now, what are this is EI and this is E0, output voltage E0. Now, I am going to find out the transfer function of this simple RC network. Those of you who know how to derive it, kindly derive it, or else you can follow my own steps. When I write these steps, you can follow that and you can write. Okay, so if I write the first equation regarding this, how will I write? R into IT, this is IT, okay, RIT plus 1 by C integral IT dt is equal to EIT, equation number 1. Then I want to get the transfer function, which means I want to get this relationship E0S by EIS. Okay. So in this particular equation, equation number 1, E0 doesn't come. So I have to write one more equation. What is E0? E0 is a voltage across the capacitance. So I can write 1 by C integral IT dt. Now you know that when you want to find out the transfer function, you have to convert all these equations into its Laplace domain, into the Laplace domain. So I'll convert that, and then taking Laplace transform on both sides. Taking Laplace transform on both sides. So you get RIS plus 1 by CS, because it is an integral, 1 by CS IS is equal to EIS, equation number 3. Similarly, equation number 2, if I take Laplace transform, I get 1 by CS IS equal to E0S. Now, in order to get the transfer function, I just have to divide one by the other. I get it as E0S by EIS is equal to 1 by CS IS divided by R plus 1 by CS into IS. Now these two cancel away and I get the transfer function E0S by EIS as 1 by CS divided by R plus 1 by CS, which I can manipulate or rearrange the terms, and I will get this as 1 by 1 plus RCS. You must be familiar with this, which I can write in general as 1 by 1 plus TS. I hope this is clear. Now, what is T called? Do you know what is the terminal or the terminology for T? What is T? T is equal to RC is called what? Time constant. Time constant. T is equal to RC is called the time constant. So, though in this case, I had taken a RC network, whatever be the system, it can be even a mechanical system having a mass and one damper only. Anyway, when you derive, you will get a similar kind of transfer function. So this transfer function is known as the transfer function of a first order system. Why first order system? Because the order of S in this case is S raised to 1. Order of the transfer function or order of the denominator. Now here, one more thing I want to tell you is here 1 plus TS is equal to 0 is a characteristic equation. I told you what is characteristic equation? The denominator of the overall transfer function equated to 0 is a characteristic equation. No, I can say that the order of the highest order of S in the characteristic equation is the order of the transfer function or order of the system, or the highest order of the S in the denominator is the order of the system. Because the order is S raised to 1 here, you call it as a first order system. For a first order system, the transfer function in general, instead of writing EI as E naught S, I can write CS by RS. CS is the output, RS is the input, is 1 by TS plus 1. Or I can put that as a block as RS is the input, output is CS, and this is 1 by TS plus 1. This is the first order system. So next we are going to consider the time response of a first order system. Time response, by which I mean transient response. Transient response of a first order system. Okay. In which case I am thinking about a unit, very important, unit step response. Okay. Though there are a number of standard signals, when you do transient analysis, it is sufficient to do an analysis using only one signal, any one of the standard signals, because the nature of the output which we are interested in, the nature of the transient response, output you call, what is response? The output itself. The nature of the transient response depends entirely on the system, number of poles of the nature of the poles of the system, on the system, and not on the input type of input. So it is sufficient to do transient analysis on a system by using only one type of standard input. Usually we do it using unit step input. Okay. So unit step simply means that yesterday we considered this as T and this as FT, and I put this as A. If this A is equal to 1, that is, if the highest magnitude is 1, you call it as unit step, and then you call that as UT. Instead of FT, you call it as UT. That is the only difference, which means UT is equal to 1 and US will be equal to 1 by S if I take the Laplace transform. Now I am going to find out the unit step response of a first order system. So what I am going to find out is I am going to derive the unit step response of a first order system. Okay. Which means, what is the transfer function of a first order system? CS by RS is equal to 1 by TS plus 1. This is the general transfer function of any first order system, be it an electrical system or a mechanical system or an economic system or a financial system. This is the transfer function, where if it is an electrical system, you put T is equal to RC or R by L, as the case may be. If it's a mechanical system, it depends on what all components were there in the mechanical system. Now, what do you mean by, all of you should be carefully listening, very attentive. What do you mean by response? Output. What is the input to the system? It's a unit step. So if I give a unit step as the input to the system, I want to find out what is CS and thereby come to CT. Convert back to the time domain. This CT is known as the response of the system. I'll explain that once again. You have a first order system. If you are going to find out the unit step response, you are asking about the response of the system if unit step is given as the input. So input RS will be US. And you are checking for CS and thereby CT. CT is the response. CS is the actual response when you take in the Laplace domain. But when you speak about response, you're speaking in terms of CT. So in this case, what is RS? If I'm going to find out the unit step response, what is RS? That is equal to US, unit step iota. So it will be 1 by S. So Cs by Rs is equal to 1 by Ts plus 1, where Rs is equal to 1 by S because you have taken a unit step. Had it not been a unit step, it would have been Rs would have been A by S, any magnitude, say 5 by S. You will have 5 as the magnitude. So here I am taking only unit step. Okay. Now Cs will become equal to, Cs is equal to Rs into 1 by Ts plus 1, that is equal to 1 by S into 1 by Ts plus 1. Okay. Now, if I want to find out CT. So if I want to find out CT, it is not sufficient to make it remain as such. I should find out, if I want to find out the Laplace inverse, I have to take the partial fraction A by S plus B by Ts plus 1. So what will be CT? 1 by S, inverse Laplace of 1 by S is 1 minus what, and this I can write it as, this doesn't have a standard inverse, so I modify this as 1 by S by 1 by S plus 1 by T. What is the inverse Laplace transform of this? E raised to minus T by T. Correct. This is your unit step response. And why is it called first order system? I said the order of S in the denominator, highest order of S in the denominator is 1. And so, or you can even say the characteristic equation, the roots of the highest order of the characteristic equation, highest order of S in the characteristic equation is 1. And so it's a first order system. So why is it called transient response? It is called transient response because Ct is a function of T. Whatever value of T you put on Ct, you will get, whatever be the value of T, you will get a response. So if I provide a table, like if I can write a table with T and Ct, okay. T and Ct 0, say 0.1 seconds, 0.5, and then I calculate the value of Ct as Ct is equal to 1 minus e raised to minus t by t. I'll get a curve which you already know. You know, we had derived this for RC network. So if this is a unit step, I get this as 1. This is your input, RT. This is T. This is your RT. What will be the shape of? What is the shape of your CT curve? Remember, it's an RC network. And where is the output taken? Output is taken across capacitance, or you are going to draw the voltage across the capacitance and how it builds up. You already know that it is in this shape, or else if you look at this equation also, you know that finally at t is equal to infinity. When t is equal to infinity, Ct is equal to 1. That is where it has reached. Is this clear? This curve is Ct. Now substituting this, when t is equal to 0, you get 1 minus 1. When t is equal to 0, what is the value of Ct? 0. 1 minus 1, 0. When t is equal to infinity, what is the value of Ct? 1. 1 minus e raised to minus t by t. 1 minus e raised to minus infinity is 0. 1 minus 0, or you get 1. Here, Ct is equal to 1 minus e raised to minus 0. That is 1 minus 1 is 0. So, in between, you have an exponential increase. This is the first order unit step response of a first order system. Is so much clear to everyone? Whom should I ask? I don't know. Anyone can volunteer, tell me. Jinta, is this clear, Jinta?
Yes, ma'am.
Okay. Okay. Now, certain things I want to tell you in this case is, something about time constant. Okay, 1. If there is some matters regarding time constant. What do you mean by time constant? In our case, it was RC because it was an RC network. What do you mean by time constant? Or what is time constant indicative of? If I have a large time constant, what do you mean by, what do you infer about the system? If you have a small time constant, what do you infer about the system? Anyone? Can you define time constant? Can you define time constant? Okay. Now, let me first find out the slope at the starting, or the initial slope of the curve. Initial slope. Slope is always found out by finding out d by dt of ct at t is equal to 0. What d by dt of 1 minus e raised to minus t by t at t is equal to 0. What is that? 1 by e raised to minus t by t, isn't it? Now at t is equal to 0, it will become 1 by t, isn't it? You get a slope of 1 by t. So the initial slope is 1 by t. Or if I draw a curve like this, okay. It has started initially with some slope. I'm going to draw a initial slope. That initial slope is this value is 1 by t. That is y-axis 1 and the x-axis will be t. So can I define time constant as a time taken by the system response to reach the final value had it maintained its original slope of increase? The system response was starting at this slope. And if it had maintained that slope, it would have reached a final value at this point. Which point? When the time t is equal to capital T. So capital T is the time taken by the system response to reach the final value had it maintained its original slope of response. Instead, it didn't maintain that. Instead, it went off exponentially, and within the time constant, it reached only this point. So within that time constant, it reached only this point. What is this value? Actually, where did it reach? Ct is equal to 1 minus e raised to minus, instead of t, t by t. At t is equal to t, Ct became what value only? Just calculate and tell me. E raised to minus 1. That happens to be 0.632, which you have already learned. So this value is 0.632, which means time constant can also be defined as the time taken by the system response to actually reach 63.2% of the final value. In actual case, the system response reached only 63.2% of the final value. Time constant is indicative of how fast a system responds to an input. Larger the time constant, sluggish is the system. Sluggish എന്ന് പറഞ്ഞാൽ it is slower is the system. Sluggish or slower is the system. Smaller the time constant, faster the system will be. I hope this portion is clear to you. It's very important. So I hope people who have an average time constant, people among you who have an average time constant has already understood. Some of you have very small time constant. You grasp it up just like that. Some of you may have a longer or a larger time constant to get these things done. They will be talented in some other things. But so you call some people tube lights, isn't it? Instead, you can always call them, you are having larger time constant. Hope this much is clear. Thank you so much. Thank you.